Okay, students, so the last part of this question. Now we have to find out the time period of the sun. Okay. Now, logically think that on the basis of what information we can find out this time period, we can link this time period with a uniform circular motion or uniform rotational motion. As you see that it is showing us that it is rotating about its axis. The sun is rotating about its axis, and we are assuming that its radius r is not going to change. Okay, so what will happen? This particle will move like this. All right, so it will always have a constant time period. Okay, it will take the same time to come back to the same position. Okay, so you already know that the equation v is equals to r omega you have studied in the rotational motion 8.4 topic, right? Whereas this r and this omega is basically the angle that it has covered in a one rotation, which is 2 pi over the time that it has taken is a time period, right? So don't you think we can get the time period from here? So that will be equals to 2 pi r over v. Now dear students, this v is the velocity of this point P, okay, on the surface of the sun, that is actually causing the Doppler shift. Okay, this point P, because we have seen in a previous question that when the point P is approaching towards earth, you had clearly seen that there was a wavelength shift, there was a blue shift. Okay, right? So this speed of this point P is causing the wavelength shift. So we can see that there is a change in wavelength to the actual wavelength of the light. Okay, is equals to the speed of that particle divided by the speed of light. Okay, so we know all the values, and remember this lambda 0 is the actual wavelength of light that we got in a laboratory from the hydrogen spectrum. Okay, so we can make a equation from here, right? So let's make an equation. So this is equals to 2 pi r over time period t times speed of light. You can multiply time on both sides, so that would we get is this thing, right? Is equals to 2 pi r over speed of light. Okay, now in the next step you can multiply lambda 0 on both sides, so 2 pi r over c times lambda 0. And then in the next step, right, you can divide delta lambda on both sides. So finally this is the equation of the time period which we want to find out. So 2 pi r over c times lambda 0 over delta lambda. Now we can put all the values because all the values are mentioned in the same question. So students, I have put all the values correctly. Okay, so let's see what do we get. So students, this answer is 2185610.27. Okay, well, it's better to write in a scientific notation, so you can approximately say 2.19 multiplied by 10 to the power 6 seconds. Okay, but it's better to convert it into the days, that how much time it will take to complete one rotation the sun takes, okay, in its rotational motion. So for this we will divide our answer with, one day we have 24 hours, and in 1 hour 3600 seconds. So let's see. So finally our answer is 25.3 days. This is a time period of the sun, and I hope that all of this solution was helpful for you.